Okay, so welcome to section 1.2, which is special triangles. Not special, similar triangles. We did similar triangles. Okay, so let's recall that right triangles, right triangles. Right means that it has a 90-degree angle, right? So right triangles have, H-A-V-E, have one 90-degree angle. 90-degree angle. Okay, so definition. Use this darker. Definition. So, number one, we have two definitions here. So, an acute triangle. Remember, acute was acute angle, right? So, an acute triangle would have an acute angle, or all angles, less than 90, because acute means small or less than 90. So, an acute triangle has all angles measuring less than 90 degrees. Measuring less than 90 degrees. Cannot write. Less than 90 degrees. Whereas, number two, an obtuse triangle. Obtuse is greater than 90. So, an obtuse triangle since it's greater than 90, we can only have one obtuse angle. So it has one angle. Greater than 90 degrees. Which necessarily means the other two are acute angles. Okay, so let's consider let's say we have an equilateral triangle. So equal or equi. Let's see if I can make a perfect triangle here. Probably not. Nope. Let's see, 1, 2, 3, 4, 5. And let's go up here. Something like so. And then something like so. I think that almost looks like an equilateral triangle. So let's call this triangle ABC, meaning the vertices are called A, B, and C respectively. And we can also have the angles called A, B, and C. So all angles will be the same in an equilateral triangle, and the sides will have the same measure. And the way we annotate that is to have the same number of tick marks through each side. So we would say in this case that triangle ABC is equilateral. Equi meaning same, lateral meaning side. Lateral, if I could write clearly, equilateral. And I don't like the way I wrote ABC. I swear I will stop drinking caffeine sometime soon. So equilateral. But then we know that the measure of each angle has to be the same. So I'm going to say the measure of angle A is the same as the measure of angle B is the same as the measure of angle C. So each angle is the same in an equilateral triangle, which means that each side is the same. So the length of side AB is the same as the length of side BC is the same as the length of side CA or AC. Okay. Okay, so that's an equilateral triangle. Now let's consider a different type of a triangle that looks something like so. What shall I do? Maybe here. 1, 2, 3, 1, 2, 3. Yeah. I don't know. I guess that's good enough. Okay, this is not equilateral. Do you know what? No, I don't like that. Let me make it a bit less fat. So let's see something. Oops. Something like so. Okay, that looks a bit better. Okay, so once again, let's call this triangle ABC. But you know what? I'm going to use a different color for this one. Let's use a different purple, a lighter purple. So ABC. So in this case, the two bottom angles are the same if the two sides have the same length. But notice that the bottom has a different length, which means that the top angle up here, let's do this in yellow, is a different measure. So this is what's termed an isosceles triangle, so triangle ABC, which means equal side in Greek. However, we're just talking about two of the sides are equal. So isosceles, iso meaning same, scalene or means side, celes. I know that seems confusing, but the difference for us in Latin means all three sides are the same. In Greek means just two of them are the same. So in this case, we get that the two bottom angles, so the measure of angle A will be the same as the measure of angle C, but it's not, the top is different. And then we get that side AB is the same as the measure of side BC, but CA is different. Then the third type of triangle is what's termed scalene. And I just said that isoscalene or isosceles means same side or equal side. This just means side in Greek, but three different sides. So if this were triangle ABC, let's use maybe this purple, it's triangle ABC. We would have that each angle, angle A, angle B, and angle C would differ. And then we would have that each side would be a different measure. So this is called scalene triangle. So triangle ABC in this case, that's supposed to be a little triangle. ABC is scalene. Okay, so hopefully you've seen these before, but if not, don't worry, you can learn them now. Okay, so for example, so let's classify the following triangles. So classify, meaning name them. Classify the following triangles. So number one, let's say we have a triangle. It looks something like so. And say I tell you that the angle down here is 70 degrees. The angle down here is 70 degrees. Well, that's 140. So the only thing that's left over is to have an angle up here of 40 degrees. So if the two bottom angles have the same measure, oops, looks terrible. No, that doesn't look any better. I'll just leave it the way it is. if the two bottom angles have the same measure, maybe I'll do this, then I know that this is an isosceles triangle, right? So isoscaling isosceles. Okay? Because two of the three sides and two of the three angles are the same. Okay, number 2, let's say we have a triangle. Kind of looks like so, something like this. And let's say that we have 60 degrees here, 100 degrees up here. So that's 160. So in order to get to 180, what's left is 20 degrees. So all three angles are different. If all three angles are different, this is called a scalene triangle, because that means that all three sides must be different too. Okay, so last but not least, of course, what do we have? So number 3, let's say we have not drawn very well. Okay, so in this case we'll have a 60-degree angle here, but all I'm going to give you is the fact that these two sides have the same length, 3 and 3. So this looks like it's an isosceles on its side, where the two same sides have been knocked over to here. Okay, but if that were true, then the two bottom angles, A and C, which for us are now here, would have to be the same. Okay, so if I know that the angles have to sum to 180, so 180 degrees will be equal to 60 degrees plus 2 times the unknown angles, so 2 times x, say. Okay, so let's subtract 60 from both sides. So we get 120 is equal to 2 times the unknown angles. So here are our unknown angles. Now let's divide both sides by 2. So 120 divided by 2 is 60 degrees. That's interesting. So each of the angles measures 60 degrees. So what type of a triangle is this? Well, all three angles are the same, meaning all three sides are the same. So this is an equilateral, so same side. All three are the same. So hopefully that makes sense. Okay, so let's consider if I have a line of length C. Where shall I put this? Maybe I'll put it here. So here's my line of length C, whatever it may be. And then I have a line of length A. Let's say it's just here. And another line of length B. Let's say it's here. So do you agree that A plus B is the same length as C? So that is, I can create C. Actually, let me just copy and paste. So copy, paste. If I take A, copy, paste, and then I put B right next to it, copy, paste. Do you agree that that has the same length as C? So I can say that C is equal to A plus B, right? If I add the two lengths, I get the length of C. So let's state this formally. So if C is equal to A plus B. C is equal to A plus B. Then we can only create a straight line, right? And what I mean by that, a straight line, if I put each end of each segment touching the other, a straight line. So I can't create a triangle out of these three lines, is what I'm saying. So what would we need? We would need that A plus B would be greater than, so A plus B greater than C in order to create a triangle. In order to create a triangle. So in a triangle, the sum of the other two sides always has to be larger than the third side. Okay, so this is a property of triangle. So properties of triangles. Okay, so let's let triangle ABC with opposite sides little a, little b, and little c respectively, be given. Then we have the following. We have that the measure of angle A plus the measure of angle B plus the measure of angle C. So if I add up all the angles in a triangle, we know that we get 180 degrees, right? That's one of the properties of a triangle. The next bullet point, we have that each A plus B, any two sides their sum has to be greater than the third side. So that means that either A plus B is larger than C, or B plus C is larger than A. Or what don't I have? I don't have A and C. So C plus A, or A plus C, must be larger than B. So if you take any two sides and add them up, it'll be larger than the third side. Okay, now the third bullet point. If the measure of angle A is larger than the measure of angle B, then their opposite sides share the same relationship. So the length of side A will be larger than the length of side B. Okay, so let's see if that makes sense. Let's take a look. At a triangle. So let's call this A with opposite side A. Let's do a different color than that. B, that's a terrible B, with opposite side little b. And C with opposite side little c. So notice that the length of side B plus the length of side C is definitely larger. If I add those two together in a line, that would be longer than the length of side A. So hopefully that makes sense for each of these. But what's more, if I look at the angle of measure A and it's larger than the angle of measure B, it should be evident that side A is larger than side B. Okay, so for example, so find theta. So find theta. So remember this is theta. The measure of the angle. So in the image below, and then find the measure of each angle. So, and then find the measure of each angle. Measure of each angle. Wow, that's not how you spell each. Nope, nope, not at all. Of each angle. Okay, so let's say we have a scalene triangle. Something like so. Yeah, okay. So let's say I have theta, 5 theta, and 3 theta. Okay. So let's call this theta, theta here. So what do I know? I know that theta plus 3 theta plus 5 theta. Let's do that in yellow, I guess. 5 theta. Well, the sum of all the angles, we know that that's 180 degrees, right? Because it's interior to a triangle, and that is the first property here. So 1 theta plus 3 theta plus 5 theta is 9 thetas, right? So I have 9 thetas is 180 degrees. So if I divide both sides by 9, I get that theta, 9 goes into 18 twice, so theta is 20 degrees. Okay, so that means that theta, the blue angle, is just 20 degrees. But 3 theta, the pink angle, is going to be 3 times 20, which is 60 degrees. And then 5 theta will be 5 times 20 degrees, which is 100 degrees. So 100 plus 60 plus 20 is 180. Okay, so there we go. That's how we found the measure of each angle in this triangle. Okay, so definition. So two triangles. Triangle ABC. Oops. Triangle ABC. And triangle DEF are termed similar. So are termed similar. That's what we're defining, similar triangles. So denoted by triangle ABC, and then a little squiggle, triangle DEF. Actually, let me get rid of the by, I don't have enough room. Denoted simply, triangle ABC, squiggle, triangle DEF. So that's the symbol for similar. So if they are both similar, if the ratio of corresponding sides, so if the ratio of corresponding sides are equal. Okay, so let's note something. So note. So similar triangles Similar triangles have the same interior angle measures. So have the same interior angle measures. However, their corresponding sides aren't necessarily equal. So the lengths of the sides in similar triangles can differ, but their angles have to be the same. So for example, that is, let's say I have triangle ABC, triangle A, B, C. Let me make this fairly pronounced. So I'm going to copy and paste. And what I'm going to do is I'm going to make this a bit smaller. Okay. So on the left, we have triangle ABC, A, B, C. And on the right, we have triangle DEF. Actually, do you know what I'm going to do? I'm going to make these a bit darker. D, E, and F. So I claim that triangle ABC, so triangle, what color should I use? I claim that triangle ABC, A, B, C is similar, so that's a little squiggle. Let me actually do that in dark red. Is similar to triangle DEF. Triangle DEF. Okay. So what does this mean? What this means is that the measure of angle A will be the same as the measure of angle D. I know that the measure of angle B up there on top will be the same as the measure of angle E up there on top. I know that the measure of angle C will be the same as the measure of angle F. However, their sides are not the same, so the opposite sides, of course, will be little a, little b, and little c respectively on the left, whereas on the right it'll be little d, little e, and little f respectively. However, the ratios of corresponding sides are equal. So what that means is that C is to F. So let's go here on the left. We have little c divided by little f will be the same as, because those are both the left-hand sides of each triangle, right? Now let's go to, come on, why isn't it working? What is going on? Oh no, it's not erasing this. Oh wow, that's weird. Okay, now I'm really confused. What was going on there? Let me put this back here. I guess the computer is thinking too hard. Thank you, Steve Jobs. Okay. Oh wow, and I just lost my ratio too. Oh my goodness. Oh boy, what is going on with this computer? Come on. Okay, so what did I have? I have the ratio of C over F will be the same as the ratio of right-hand side to right-hand side, which will be the same as the ratio of bottom to bottom. So, right-hand side was A over D, and bottom to bottom is B over E. And the reciprocals too. I could flip all of these upside down to get, let's flip them upside down, a similar relationship, which is, where shall we put that here? Ratio, ratio, ratio. So flipping these ratios upside down, we'll have F over C is the same as D over A is the same as E over B. So that's doing between the two. Another way we could say is that left is to bottom. So another way we could do this, we could say that, actually this would only be 2. In the left-hand triangle, if I have C over B, that ratio will be the same as F over E in the right-hand triangle. Because notice it's left side over bottom side. And we could do that for the ratio of any groupings. So let's do one more just for good measure. So let's say I have B over A, bottom over right. So B over A on the left triangle would be bottom over right, E over D on the right-hand triangle. Okay, so this is what we mean. Corresponding ratios are equal. The side lengths are not equals, but the ratios are. Okay, so let's recall. So if two lines intersect, and I'll draw a picture in a moment, intersect, then the two sets of opposite, the two sets of opposite interior angles, so sets of opposite, i.e. vertical, in angles are congruent. And congruent means that they have the same measure. Boy, congruent. Okay, so let me draw a picture. Let's do two lines crossing one another. So I've got one line here. Remember, a line has arrows on both ends. Let's call this line L. Very clever for a line, calling it L. Let's have another line here, little m. Okay, so what we're saying is that if I look at the angle here, this angle and this angle here, let's call them both alpha. They're both the same because they're opposite interior angles, whereas this angle here, we can call these two angles beta. Remember, we always name angles after Greek letters. So angle beta. So opposite interior angles are equal. Okay, so for example, and this will be the last example for this section, and then I will stop. So example. So find the lengths of the missing sides in the following illustration. So find the lengths of the missing sides sides in the following. Okay, so I'm going to give you an illustration that looks something like so. We're going to have a right triangle here. And I'm going to kind of extend this out to a smaller right triangle here. And I'm going to connect the two ends here. Okay, good enough for government work. Okay, so this is a right triangle here connected to another right triangle down here. I'm going to give you that this length is 30. This length here is 10. And what else should we do? Do I have enough information? Let's call this x minus 4, x plus 6, and is that enough? Yeah, I think that'll be enough. Okay, so I'm going to name these. Let's call this A, B, C for this first triangle. And what do I know about the angle here? Well, those look like vertical angles, right? So I know that that measure on either side of B must be the same. And let's call this point E and D. Okay, so these are both right angles, so that's 90. I know that whatever the yellow angle is, it's the same. So by default, the remaining angles must be equal. So angle A has to be the same as angle D, right? So that I can just gather by default. There's no other choice. But what do I know? If all three angles are the same, then triangle ABC is similar to triangle DB. Let me see if I can do this right. A is the top, so that's triangle DBE. Right? They're similar triangles because they all have the same measures. So what that means is that the ratio of side to sides are the same. So what that means is I can set up a ratio to try and solve for x. Okay, so let's look at the left-hand side. I claim that x plus 6 is to 30. So as 30 is the hypotenuse there. Now let's look at the right-hand side. X minus 4 is to 10. And that's because these are similar triangles. So I'm going to go ahead and cross multiply the 30 up here and the 10 over here. Okay, maybe I should have put this somewhere else. Yeah, do you know what? Let me move this down to where I have a bit more room over here. So let's cross multiply. So what I get then is 10x plus 60. If I multiply the left-hand side by 10, that's going to be equal to 30x minus 4 times 3, and so that's 120, right? So I'm going to simultaneously subtract 60 from both sides. And no, let's add 120 to both sides and subtract 10x. Okay, so let's subtract 10x from both sides. And let's add 120. So plus 120 plus 120. So what does that give us then? on the left, the 10x is reduced, and on the right, the 120 is reduced. So what do I have? I have 60 plus 120 is 180. And that's going to be equal to 20x. So dividing 18 by 2, I get 9. So 9 must be equal to x. Okay, so if that's true, then x minus 4 will be what? 9 minus 4? Actually, let me color code this correctly. So this is 9 minus 4, which will be 5. Let me put the 9 in there in pink. And over here on the left, I'll have 9 plus 6. So 9 plus 6 is 15, right? Okay, so that's interesting, because notice how 30 is 15 times 2. Actually, let me not use yellow. Let's use hot pink. And 10 is 5 times 2, right? That means the hypotenuse is twice the smaller side. So if the hypotenuse is twice the smaller side, we know that in a 30, 60, 90 right triangle, the ratios are 1 to root 3 to 2. Hypotenuse is twice the small size. Okay, so I can find the remaining sides from there. I claim, let me copy and paste this, so copy. I claim that for the left-hand side, what will I have? I need to find this side here. Well, I claim it's going to be root 3 times the small side. And the small side was 15, right? So I can multiply through by 15. So I claim that the small side here is 15 times the square root of 3. Or, for the triangle on the right, the small side there was 5. So in order to find the long side here, I would just need to multiply through by 5. So that gives me 5 root 3 for the long side there. Okay, so I hope this makes sense, and I will see you guys in the next video.